This video will go over numbers 1 and 2 for the polynomial long division. So looking at number 1, I rewrote it on a separate sheet of paper so I had enough space to write it big enough to show you. So we have this polynomial divided by this polynomial. Okay, to set this up, I would write this on the outside and then our division sign. So don't mix up division and square root. Square root would have the hook on the bottom, division does not. So before I do the top bar, I'm going to write this part. When we write this inside our division here, we need to include every term, so from greatest to least, and every term meaning this is 5, 3, 2, 1. So I'm missing 4. There should be 5, 4, 3, 2, 1. So looking here. So this would be showing every term, 5, 4, 3, 2, 1, and a constant. So if I'm missing one of these, I'm going to need a placeholder of 0. So this is 2x to the 5th. I'm missing x to the 4th, so I have 0x to the 4th minus 15x to the 3rd minus 9x squared plus 11x plus 12. And now I'll just do that above it. So this is just like doing long division with just numbers without variables. It's just a little bit different. We have to look at the first terms when we go to divide. So looking at these first terms, I look at the x, you see that, and I look at 2x to the 5th. So off to the side here, I would do, well, what is 2x to the 5th divided by x? 2x to the 5th divided by x, you do the subtraction rule for your exponents, would be 2x to the 4th. So that's my first number for the division, and I'm going to write it over my other x to the 4th here. So I have 2x to the 4th. Okay, so for this next part, I'm going to multiply this number on top to this binomial. So I'm going to make this blue. So we have 2x to the 4th, and I'm going to multiply that by x plus 2. Okay, so I just rewrite that over here, that I'm multiplying this by the x plus 2 that I'm dividing by here. So when I distribute 2x to the 4th into here, I will get 2x to the 5th plus 4x to the 4th. Okay, so from here we subtract. So I will do 2x to the 5th minus 2x to the 5th and 0 minus 4x to the 4th. Okay, so when you do this, the first term should always, always, always cancel. If this doesn't cancel, then you didn't do the division right over here. Okay, so now I'm going to subtract 0 minus 4 is negative 4, x to the 4th, and then I will bring down my next number, my next term, negative 15x to the 3rd. So I don't need to bring it all down. It's kind of a waste of writing, just doing one term at a time because I only have 2 terms here. So I'm only bringing down 2 terms at a time. Okay, so again, I look at my first term that I'm dividing by and the first term here. Off to the side, I'm going to do 4x to the 4th divided by x. Subtraction rule, 4 minus 1 would be x to the 3rd, would be 4x to the 3rd. So this is going to be my next term up here. Oh, it's negative 4, so this would be negative 4x to the 3rd. So this will be minus 4x to the 3rd. Okay, so again, I'm going to multiply this by what I'm dividing by. So this will be right over here, 4x to the 3rd times my x plus 2, and distribute negative 4x to the 3rd. So this will be negative 4x to the 4th minus 8x to the third. And then subtract. So I'll do 4x to the fourth minus negative 4x to the fourth and negative 15 minus negative 8. So what's often forgotten here is the subtraction. We're subtracting these numbers, not adding. So these cancel. First term should always cancel. Negative 15 minus negative 8. Let me just double check my math here. Be negative 7 x to the third, and bring down the next number. Okay, so I hope you're catching on to the pattern here. The next one, I have 7x to the third. I look at my first number again. I have 7x to the third. Off to the side, I'm going to do negative 7x to the third and divide it by the first term here. And this will become negative 7x squared. So this is my next term. I'm going to write it here. So this negative 7x squared. Okay, now I'm going to multiply this by what I'm dividing by. So I'm going to go over here, negative 7x squared times my x plus 2. When I distribute, I'll get negative 7x to the third minus 14x squared. And then now we are subtracting. Again, negative 7 minus negative, it's like negative 7 plus 7 cancels. Negative 9 minus negative 14 is like negative 9 plus 14. And then bring down your next number. Make sure you include the signs when you bring down these next numbers. So just repeating this pattern here. So I have 5x squared off to the side. I'll do what's 5x squared divided by x. And x will cancel, leave me with 5x. So that's going to be my next term. Another color here. This one. So 5x. So this is a positive 5x. So I won't just put 5x. I'm going to do plus 5x. Okay, and then rewrite it down here. 5x. And it's going to be that 5x times x plus 2. Okay, distributing, I would get 5x squared plus 10x. Just distributing in, and then subtracting. So this should always cancel. And then 11 minus 10 is just going to be 1x, just x, and then bring down the 12, plus 12. Okay, so I look here, I have x. So I can still divide this because this x, the exponent for this x is equal to this exponent. So we can still divide x divided by x would just be 1. So 1 is going to go up top. I'll make that this other color here. That would just be plus 1. And then 1 times my x plus 2 is just going to equal the same thing. Just x plus 2 and subtract. So this first term cancels. 12 minus 2 is 10. Okay, so that's your long division. We look at the first terms always to decide what number is going to go up top. Whatever number you put up top, you multiply it to what you're dividing by, and then subtract. So you just keep repeating that process until the end. So 10, this should be a positive 10. So 10 is our remainder because I cannot divide x into 10. 10 doesn't have a variable, so we can't really do that. So what your remainder, what you do is you write it next to your polynomial, we do plus, and I'm going to do 10 over what I divided by, x plus 2. So that always becomes, if you have a remainder, it always becomes a fraction at the end. So this is our final answer for the first one. Okay, let's look at the next one. So I'm looking at my exponents. I have 5, 4, 3, 2, 1 constant. So that's great. I don't need any placeholders. I'm going to write my 3x minus 5 on the outside. And then this on the inside. So I have 9x to the 5th, and x to the 4th, minus x to the 3rd, 12x squared. So we're using a lot of our different rules that we've learned. We're using our exponent rules to determine what the next term will be up top, and our polynomial adding and subtracting like terms. Okay, so same thing again. We look at the first term. Off to the side, I'm going to do this divided by the 3x. So I have 9x to the 5th divided by 3x. 9 divided by 3 is 3. Subtraction rule. 5 minus 1 is 4, so it's x to the 4th. So there's my first term that will go up top. So this is 3x to the 4th. And then I'm going to multiply that to what I have here. So I have 3x to the 4th times 3x minus 5. So notice how I'm making sure everything lines up when I do this. When I do this multiplication, I put it off to the side a bit more. Distribute to get 9x to the 5th minus 15x to the 4th. And then subtract. So I just want to circle this so you can see where that number came from. So when I subtract, first term should always cancel. Negative 9 minus negative 15 is a positive 6. Since I only have 2 terms here, I'm only going to bring down one more. This, again, if this was 3 terms, I would be bringing down, so I always have 3 terms down here. 6x to the 4th, I'm going to go off to the side and do 6x to the 4th divided by 3x. Okay, that will give me my next number of 6 divided by 3 is 2. Subtract, I get x to the 3rd. So this is a positive 2x to the 3rd, so this will be plus 2x to the 3rd. And I'm going to multiply it by this, 2x to the 3rd times 3x minus 5. Okay, distribute here. So this will become 6x to the 4th and then minus 10x to the 3rd. Now we do the subtraction. 6x to the 4th, that should cancel. Okay, so again, if that doesn't cancel, your first terms here, then you did something wrong with the division. So those should always cancel. So this is like a negative 1 minus negative 10. So negative 1 plus 10 is a positive 9. X to the 3rd. Bring down the next term. And we do the same thing again. So we have 9x to the 3rd. So off to the side, I'm going to divide 9x to the 3rd by 3x. And I have 3x squared. That is my next number, this 3x squared. And it's positive, so we have plus 3x squared. And then I'll do 3x squared times 3x minus 5. So 3x squared times 3x is 9x to the 3rd, and then times negative 5 is minus 15x squared. And subtract. these cancel. Negative 12 minus negative 15, so negative 12 plus 15 is positive 3x squared. Bring down the next term. Okay, I look at my 3x squared and my 3x and divide. So 3x squared divided by 3x. The 3's would cancel and I'm left with just x. There's my next one. Just x plus x. And then we do x times our original 3x minus 5. So this becomes 3x squared minus 5x. And subtract. This cancels. 1, so this is 1x, 1 minus negative 5, or 1 plus 5 is 6x. And here's our last term. Okay, so 6x, we can still divide that by 3x. Three goes into 6 2 times, and the x's cancel. So here is my last term of 2. Do plus 2, so positive 2. And then this 2 times 3x minus 5. Distribute to get 6x minus 10. And subtract. 6x minus 6x cancels. Negative 11 plus 10, so the negative becomes positive, would be a negative 1. So the reason why we would stop here, because if I go off to the side and do negative 1 divided by 3x, I cannot further reduce that at all. So that's why this is our remainder, and I would write that as the remainder of negative 1 over what I'm dividing by, 3x minus 5. And there is our answer.